Good morning, students. Today I will discuss a problem which I have given in the class test. Okay, so the problem is the potential field at any point in space containing a dielectric material of relative permittivity of this much 2.1 is given by this. So this is the potential they have given, and this unit is in volt. So you are asked to calculate the volume charge density at this point 253. Okay, so how to calculate? For that we will be using Poisson's equation. Poisson's equation. So what was the Poisson's equation? It is basically del square V minus rho by epsilon. Okay, better to say it is the volume charge density. So this is the rho V and this is your del square V. So this comes from basically from your Maxwell's equation. This is suppose or Gauss law, whatever you say. So this divergence of D is basically your rho by, is basically rho, it is not rho, by epsilon. So it will be only basically rho, and we know that D is equal to permittivity into E. This is also known to us. Now if you put this value here, you will get del dot epsilon naught E is equal to rho, or say it's a rho V. Now you see, I can write from here del dot E, since this is a constant, since if I take this permittivity is not changing, then I can take this outside and I can take this in the right hand side. So I can write rho V by epsilon. And we know that electric field is related to potential by this formula. Okay, so if you put this here, you will be getting del dot del V, and then your minus, and we will be having this. So now you see this I can write as del square V, and I can take this negative sign in the right hand side. So this is the equation. So this is basically the Poisson's equation, and this equation I will be applying here since the potential is given. Okay. So this is basically your Poisson's equation. So with the help of this equation, we will be solving, we will be calculating the volume charge density. So let us see what is the formula of this del square V. So del square V is basically, the formula was, if you recall, it is d square V by dx2 d2V dy2 d2V dz2. Okay, that means I have considered the potential is a function of x, y, z. Hence we are considering 3D. Okay, so if this is a 3D form of the Poisson's equation, and of course you can see there is no unit vectors here, so this is basically a scalar quantity. Okay, now you can see what you need to do. You need to calculate these terms individually, and then you can sum up to get this value, and now you can multiply with the permittivity, then you will be getting the volume charge density. So this is our basically the problem. So what you can do here is we need to calculate this term del square V first. So let us say del square d2V dx2, it will be basically d2 dx2, and the potential is given by this. So we have 5x2 plus 3yz square plus 6xz. Now if you differentiate it, if you take the double derivative of this equation, of this function with respect to x, then you will be getting this value. So let us first differentiate it. So if we differentiate this with respect to x, then you see that we will be getting, if I differentiate for the first time, then you will be seeing this will be 5 into 2 x y. There is no x term here, so it will be basically, we can treat this as constant, so it will be basically 0, and here we have our x, so this we can write as 6z, and dx will be 1. So this is basically what you got after first differentiation. And again if you differentiate it, so this will be basically 10y, because again I am considering the y to be constant, and this term, there is no x term here, so basically all will be 0. So we have only 10y. This much will be there. Remember one thing, I have made a mistake here. What is the mistake? I should have write this as partial derivative. This should not be d. Why? Because we are taking, when we are differentiating with respect to x, we are considering the other two parameters, that is yj, to be constant. That means the function is, this potential is a function of x, y, z though, but we are taking the differentiation with respect to x, then y, then z. Okay, so I should write as, this should be the partial derivatives. Okay, this should be also. So this is what you got after, if you calculate this, you will get the del square b del x2 is basically 10y. Okay, now our next job will be to calculate this one, del 2v del y2. So this will be basically will be again differentiating with respect to y this time, and let me write the function once again. So this is yz square plus 6xz. So if you differentiate this with respect to y this time, so if I differentiate for the first time, then you will be getting, there will be 5x square, because this time x will be, we will be treating as constant, so this will be 5x square only. Here we will be having 3z square, and here we will be having 0, because there is no y term here. Okay, so this much we will be having. Now again, if you differentiate, you can see from here there is no y term in this, there is no y here also. So basically the differentiation will be basically 0, because there is no y term. That means this we can treat as a constant, so it will be basically 0. Okay, so now our next task will be to calculate this one. Now we will calculate with respect to j. So this will be basically 5x square y 3yz square plus 6xz. So this will be basically, now we will be differentiating this function with respect to z only. So you can see there will be no, there is no z here, so it will be basically constant. So it will basically, the differentiation will be basically 0. So we have 0. Let me do it one by one. So after first differentiation, we will be having 0. Then we will be having, this will be 2 will come out. That means it will be have 6y z. If you differentiate this with respect to z, and here we will be having only 6x. Okay, now again if you differentiate with respect to y, you can see this will be only 6y, and there is no z here, so you will be having 0. So basically 6y. Okay, so that means what we have ultimately, what we got is basically, for this case we got 10y, for this one we will get 0, and for this we have 6y. That means your del square V is nothing but 10y plus 6y, that means 16y. Okay. And now this is of course should be equal to this one minus rho V by permittivity. So what we have basically minus rho V by the permittivity is basically 16y. This is what we have. And you can see that from here I can write rho V as minus epsilon 16y. This I can write. Okay. Now let us see. We need to calculate the volume charge density at this point 253. So you can see if I find the volume charge density at this point, that means we have rho V minus the permittivity 16y. Tell me what is the value of y? It will be basically 5. If I want to calculate the volume charge density at this point, then you can see the y is basically 5. So what we have, and this permittivity you can write in terms of free space. This is basically the permittivity of free space into the relative permittivity of the medium, that means the dielectric, and we have 16 and the y is basically 5 here. Okay, and this, you know, the value of this epsilon naught is basically 8.854 into 10 to the power minus 12, and this relative permittivity is 2.1. It is given in the question, and 16 into 5 we can write 80. So if you calculate this, you will be getting 1.487 into 10 to the power minus 9 coulomb per meter. This is the charge per unit volume. Okay, so this is what you got, and of course we are taking the magnitude. So you can neglect this negative sign, means if you consider only the magnitude, that means if you consider only the magnitude. Okay, so this is what you got. So basically from the Poisson's equation we have calculated these terms individually. These are partial differentiations, and then we have calculated the volume charge density for this point. So for this point we have y is equal to 5, 16 is already there, and I have written this permittivity in equal to the relative permittivity into the permittivity of free space, and for the permittivity of free space is basically this one in SI unit, and if you calculate this you will be getting this one. So this is your answer. Okay, so I hope you have understood this. So our second problem was in a field, this is the field, E is equal to minus 50y ax cap minus 50 xay cap plus 30 az cap. This is in volt per meter, that is the unit of electric field. Calculate the differential amount of work done in moving a charge of this magnitude 2 microcoulomb a distance of 5 micrometer from A to B. That means you need to bring a charge from A to B, and in that region we have an electric field of this. Okay, so what will be the amount of work done? See, they have used the word differential amount of work done. So differential means you need to just calculate the, if I denote work done by W, then differential work done will be del W. Okay, so some of you have made mistake in the test that you have integrated. So integrated is the total work done. So that is not required, that is not asked here. They are asking for the differential amount of work done. So that means what we have, the formula is del W is equal to minus QE dot dl. Okay, so you can think like this. This is the work done is equal to force into displacement. You know this. So this is basically the force, and this is the displacement. You can think like this. Just what you have learned in classical physics. And of course, is minus sign because we are taking the charge against the field, against the force of the field. Okay, so that is the minus. This is already I have explained in the class. So basically, we need to calculate this one. This much you need to calculate. So here our concern is Q is known to us, E is also known to us, it is already given, but we don't know what is dl. So if we can calculate dl first, then you can easily calculate del W. Okay, so our first objective will be to calculate dl. What will be my dl? Okay, so let us see what is dl. So the dl is basically a length, the distance you need to travel. So they already mentioned a distance of 5 micrometer. So that means they have given the magnitude of that vector. That means you can say it is the magnitude 5. Okay. And you need to multiply this by the unit vector along which direction you are bringing that charge. So here for this case we are bringing from A to B. So let us write the unit vector to be from A to B. This is the unit vector. Okay, so this is the magnitude, and the direction will be taking that charge, that 2 microcoulomb charge from A to B. So this is the direction should be from A to B. Now you know how to calculate the unit vector. So what will be my unit vector? It is basically 5, and the unit vector, this one you can calculate. You can I have already discussed in the class that if there are 2 coordinates given, 2 points are given, then you can calculate the unit vector. That means, say we have a point, let us write this in this way. Let us the 2 points to be A and B. So let us say the coordinates will be XA, comma YA, comma Z. And for this point B, we have XB, YB, ZB. You can write this in this form. And your unit vector from A to B will be simply take subtract the coordinates, these points, this axis value. So we have XA minus XB. But remember one thing, this is our initial point and this is our final point because we are taking from A to B. So this is the destination. So what you need to do is, you should write the coordinate of B first. That means it should be, when you are subtracting the x values, this should be xb minus xc. Okay. And this is of course for x, so our unit vector will be along the x direction, plus, now you subtract this two, the y. So yb minus ya, and we have the unit vector along y direction, and lastly you need to subtract this two. So we have zb minus a z. This is the unit vector along z direction. So this is when they have asked that you have taken the charge from A to B. If they ask from B to A, then this should be xa minus xb. This should be A, B. If they say like B, this is A, this is B. If you are taking the charge from B to A, then this should be xa minus xb. So you should write A first, the destination coordinate first, the x value first. Like that way it will go. Okay. So this is what we have. So this will be the vector of AB, but since we need to calculate the magnitude, the unit vector. So what you need to do, this is the total vector, you need to divide it by the magnitude. Then you will be getting the unit vector. So this is the basic the vector along A to B, and the unit vector, to get the unit vector, you need to divide it by the magnitude. That means, if you recall that we generally write AA, if A is a vector, so this is the A vector. If we divide it by the magnitude of A, then you will be getting the unit vector. So this is the unit vector formula. Same thing I am doing here. Instead of A, we have this vector, and the magnitude will be this. So magnitude, you know how to calculate. This will be xb minus xa whole square plus yb minus ya whole square plus zb minus za whole square, and of course you need to take the root. Okay, so this is the magnitude. So if you follow this procedure, this one, then this is basically our A cap AB. So now if you calculate this, you see what is my xb here? Xb is basically this 2. So this is 2, this A is 1, YB is basically 4, YA is basically 2, ZB is 1, Z is equal to 3. Now you can easily calculate the unit vector. So let me write this. So that means what I have discussed just now is basically how to calculate the unit vector given the 2 points. Okay. So basically we have, first of all, subtract this from this. So we have 2 minus 1, and this is for x. So we have the unit vector along x plus 4 minus 2, this will be for y. So yb minus ya, that is 4 minus 2, this will be along y direction, and then z is 1 minus 3. This will be for z. And now if I divide it by the magnitude, what is my magnitude? Magnitude will be, this is 1, so 1 square plus 2 square, and this is minus 2 whole square. And of course we will be having a root. Okay. So ultimately if you solve this, you will be getting the thing is 5 by 3. So this is the 5, and this comes out to be 5. See, this is 4, this is 4, this is 1. So 4 plus 1, that is 8, 9. Root over 9 is basically 3. So 5 by 3. And this, we have, this is 1 ax cap. So only we have ax cap plus 2ay cap, and we have minus 2 az cap. So this is what we got is as dl. So this is dl. Now you can multiply here. You can take the dot product with this E, and if you multiply by charge, then you give it the work. So this is the basic thing. Okay. So now let us calculate the, so let me write this as dl 5 by 3 ax. Now see, let us calculate del w. It will be basically q. E is basically this. So minus 50y ax cap minus 50x ay cap plus 30 az cap, and this should be dot product with this dl. So dot product with dl means they have 5 by 3 x cap plus 2ay cap minus 2az cap. So this one I have. Okay, And what is the value of this charge? It is given 2 microcoulomb. So what you can do, you can keep this is 2 microcoulomb means 10 to the power minus 6, do a minus here, and it's a 5 by 3 here. Now you take the dot product of these two vectors. So what will you get? You will be having minus 50y x dot x is basically 1. So we have only minus 50. And for this case we will be having plus 2 minus 50. So we have minus 100 x and ay dot ay will be 1, and this will be minus 60. 2 into 30 is 60, this much will be having. So this is what he got. Okay, so now if you calculate this, you will be getting 867 picojoule. Okay, so this is what you will get. But the problem is, see, if we have here we have a problem. Basically, we can see that we have at the point, that means our destination point will be from A. So what you need to do here is basically put the values of the A coordinate. Okay, so then you will be getting this value. That means, okay, let me not jump this step. So at the point A, we have 1, 2, 3 as the coordinates. So what we have is basically minus 2, 10 to the power minus 6, 5 by 3, and 50y. What is the value of y at this point? Is 2. Minus 100, x value is 1. So this is minus 60. So this is what we have. Now if you calculate this, you will be getting, this will be 100, this will be minus 100, so that will be minus 200, and we have 60. So we have 260 from here. So 260, so we have this minus, if I take common, this minus will vanish. So we will be having only 10 by 3 into 260. That means from here we have got 260. Minus 260 basically, and we will be having 10 to the power minus 6. So you can see, if you calculate this will be like something 826 by 3 is how much? It is like 8, 24, 20, and then 6. This will go like this, and we will be having this 10 to the power minus 4. 10 to the power minus 6, and here we have a 0, here we have 0. And this will be 8.6. Okay, so you can write from here is basically, and one thing I have missed here, we have 5 micrometer and we have 2 micrometer. That means we'll be having another 10 to the power minus 6. So this, we are 10 to the power minus 6 for this one, for 5. So we'll be having another 10 to the power minus 6. So basically we'll be having another 10 to the power minus 6. So let us write this in this form. 2600 by 3 into 10 to the power minus 12 joule. Now you can see what we have calculated. This is 866 something that you can calculate, and this you can add as picojoule. This is picojoule. Okay, and approximately you can take 867. So this will be your answer. Okay, so let me repeat it once again. So first of all, you need to calculate DL, which we have calculated from here. Then you simply apply this formula. And remember one thing, this 5, this is basically micrometer. So we'll be at 10 to the minus 6 will be here. So there will be another 10 to the minus 6 here. And this is 2 microcoulomb. So we'll be having another 10 to the minus 6 here. These two will make 10 to the minus 12. And the other things will be the same. And so that the initial point, what you are seeing, that the work done will be this much, 867 picojoules. So this will be your answer. I hope you have understood. And here we have another problem. So here the potential is given, V is equal to 2x plus 1 square, y plus 2 whole square, z plus 3 whole square. And this potential is in volt. And this potential is in free space. So you are asked to calculate the potential at this point. 2 minus 1, 4. So this is the potential, V is the potential. Then you need to calculate the electric field. Then you need to calculate the flux density. Then you need to calculate the volume charge density. So this is what you need to calculate. So this problem is very easy. So let us calculate the potential. So potential at the point P, 2 minus 1, 4. So see, the potential is already given here. So you need not to calculate any extra things from here. So what you have, 2x plus 1 whole square, y plus 2 whole square, z plus 3 whole square. Now you see, at this point, 2 minus 1, 4, we have, this is x, y, z. So put the value of x. So what is the value of x? Is basically 2. So what we have, 2 plus 1 whole square. What is y? Minus 1 plus 2 whole square. And we have z. Z is 4, so 4 plus 3 whole square. So what we have, 2 plus 3 square, this is 1 square plus 1 square into 7 square. So what you have, if you calculate this, you will be getting 882 volt over. So this much you need to do for this one. Okay. Next, what you need to calculate? The E. E is the electric field. So our next task will be to calculate E. So E, the electric field at the point this. So first of all, what is the formula for E in terms of potential? E is equal to minus del V. Remember, V is a scalar function, so I haven't given any vector sign here. E is of course a vector. Here this del operator, we have unit vectors there. So from there we will be getting a vector. So this is basically minus del V. This formula is also known to you. And I can write this del V in 3D form because electric field is a function of x, y, z. So what will be my 3D form? We have del V, del x, and we have the unit vector. Since this is a vector, there should be a unit vector here. And we have del V, del y, ay cap plus del V, del z, az cap. So this is the electric field. And remember, this is the x component of electric field, this is the y component of the electric field, this is the z component of the electric field. Okay. So let us calculate this del V, del x first. So from here you can see, if I differentiate this function with respect to x, what will we get? So we will be having, these two will be constant here. So we will be having 2y plus 2 whole square, z plus 3 whole square. And what will be the differentiation of this? It will basically 2x plus 1. Okay, if you differentiate this. So this much will be for del v del x, and you have the unit vector. Okay. So basically we have minus 4 and this. Similarly, we will be having, we can calculate this one. So what will we have? So del v del y, that means this time this 2 will act as a constant, this x and z term will act as a constant. So we will have 2x plus 1 whole square, z plus 3 whole square. And if you differentiate this, so we will be having 2y plus 2. This much will be having. Similarly like this, means exactly like this. So this will be, and of course the unit vector. Lastly, you need to calculate del v del z. Del v del z means this one. So this will act as a constant. So let us write that one first, x plus 1 whole square, y plus 2 whole square. This will be constant. And if you differentiate this, we will be having another 2 here, and we will be having z plus 3. This is z plus 3. And of course, we should give the unit vector, this one. So some of you have omitted this unit vectors, that is why the marks have been deducted there. So remember one thing, electric field is a vector quantity. Okay, so this much what we have, and of course this minus will be there, because we have E minus del. So this is what we got. And if we calculate this for the point 2 minus 1 4, that means instead of x you should put 2, instead of y you should put minus 1, instead of z if you put minus 4, then you will be getting a complete vector, and you will be getting some values, numeric values as a magnitude. So let us see. So if you put this value here, you will be getting this will be basically minus 5.88 ax cap minus 1764 ay cap minus 252 az cap. So this will be your answer. That means in that expression what you got, put the value of this. So at this point, put x is equal to 2, y is equal to minus 4, and z is equal to 4. If you put this in the equation what we have seen earlier, then you will be getting this. I hope it is clear. Now let us calculate the D. What is D? Flux density is related to electric field by this formula. T is equal to epsilon E. And remember one thing, what is this epsilon? This is, I told you, this is basically the permittivity of free space into the relative permittivity of the medium. But here, if you see, here it is mentioned that it is for free space. That means for free space, we will be having only this much. That means this relative permittivity will be 1. And we have E. E, you have already calculated this. So if you now multiply, epsilon now will be 8.854 in 10 to the power minus 12 multiplied by this E vector. This E vector. If you multiply it, you will be getting minus 5.21 ax cap minus 15.62 ay cap minus 2.23 az cap, and your unit should be nanocoulomb per meter square. It should be nanocoulomb per meter square. So nano, you can see it's nano means 10 to the power minus 9. So it will obviously come because we have 10 to the power minus 12 term here. Okay, so it is been nanocoulomb per meter square. This is the flask density D. So after this, we have calculated V, we have calculated E. So this is the actually the part C. So this is, we have already calculated D. Now our last point is to calculate this rho V. Okay, so let us see what will be my rho V. So for to calculate the rho V, we know that del dot D is basically rho V. This is known to us. And we can write from here del dot E is equal to rho V by the permittivity. And here you have free space, so you can write epsilon naught. Because D is equal to epsilon naught E, we have seen this. So what we need to calculate, if we calculate the divergence of this E, if you calculate the divergence of E, then you will be getting, and if you multiply this by the permittivity of free space, then you will be getting the rho V. Okay. So what will be my divergence of E? So divergence of E is basically, so let us write rho V is equal to epsilon naught by del dot E, and this del dot B, this divergence of E is basically, we will be getting del Ex del X plus del Ey del Y plus del Ez del Z. So this is for divergence formula. Okay, so that means what we have done, I have considered that E, I have written in terms of this. So E, we have Ex, Ax cap plus Ey, Ay cap and Ez, Az cap. And we have del X, Ax cap plus del Y, Ay cap plus del Z, Az cap. So if you take the dot product of these two, what will you get? You will get this. Okay. So now see what will be my this X part. What will be my this Ex, and what will be my Ey? What will be my? So you can see this is basically our Ex. And this is Ey, this is Ez. Okay. So if you can recall that what we have seen from here is basically, let me write this once again here from. We have del V del X. Del V del X means, again, if you differentiate this, that what we have already done earlier, we have seen that we will be getting minus 4 x plus 1 y plus 2 z plus 3 whole square. That means if you differentiate this, you will be getting, this is already what you have done earlier. You can pause the video or you can rewind the video and you can check. This is what we got. This will be the unit vectors. And for this case, we will be having dv dy. dv dy will be basically, again there will be minus because of this minus. So this is minus 4 x plus 1 whole square y plus 2 z plus 3 whole square ay. And for this one, we have 4 x plus 1 whole square, y plus 2 whole square, z plus 3. Az cap. This is what we have. So this is nothing but our ex. This is nothing but our ey. This is nothing but our ez. Okay. Now if you differentiate this with respect to x, so this is basically our ex. This is ey. This is ez. Now if you differentiate this with respect to x, then what will you get? So permittivity will remain as it is. So if you differentiate it, you will be getting this term will get omitted simply. This term will not come in the picture and these other terms will be present. So we have minus 4 y plus 2 whole square, z plus 3 whole square. Similarly for this one, this term will omit, will not come into the picture and we will be having only this. So we have minus 4 x plus 1 whole square, z plus 3 whole square. Okay, and remember there will be no unit vectors because there is no unit vectors here. And from here you will be having 4 x plus 1 whole square, y plus 2 whole square. This is what you have. Okay, so that means we have differentiated this with respect to x, this we have differentiated with respect to y, and this with respect to dz, because this is our formula. Okay. Now you have been asked to calculate the charge density, volume charge density for this point, 2 minus 1, 4. So what you can do, instead of x, you can write 2, instead of y, you can put minus 1, instead of z, you can put 4. And if you take multiplied by the permittivity, you will get rho v. So ultimately what you will get is basically minus 17.67 nanocoulomb per meter. This is what you will get. Okay. Remember this value is 8.854 to the minus 12 and this will automatically change. Okay, so this is our problem. So what you need to do here is basically for the last one we will take the divergence of E. So divergence formula is this, which I have already explained, and this is the component of E along x direction, component of y, component of E along y direction, and this is the component of E along z direction, and we can calculate from here. This Ex is nothing but this, Ey is nothing but this, and Ez is nothing but this. Of course, you need to consider the minus side. And since we don't have enough space here, so we already have roughed out that. So what we have calculated in the second step, you can directly get this. From there, you can directly get this. That means I have differentiated this. This is the Ex, this is the Ey, this is the Ez. I have differentiated this with respect to x, this one with respect to y, this one with respect to z. Then you will be getting this much. And then if you put the value of x, y, z for this point, then you will be getting this. Okay, so this is the problem. I hope you have understood. If you have any problem, you can call me. Thank you so much. Take care.